Welcome to the Physics Frontiers podcast, where we explore the most groundbreaking ideas reshaping our understanding of the universe. Today, we're diving into something that's both fascinating and complex: David Deutsch's constructor theory. It's a framework that challenges how we think about tasks and physical processes, and the implications of such theories could be monumental. So, let's break it down. Think of constructor theory as a completely new way to look at physics. Not just equations and calculations, but as a set of tasks and the systems that can perform them. Pretty mind-bending, right? It shifts the focus from what happens in physical systems to what tasks can be accomplished based on the laws of physics. Now you might be asking, what does that mean for us? Well, this theory introduces what we call universal constructors. Imagine a machine that can build itself from a list of tasks, like a recipe that not only tells you what to do, but can also replicate itself by following those steps. It's almost like how life replicates itself through DNA. Here's where it gets particularly interesting. Constructor theory incorporates elements of quantum mechanics and even touches on concepts like gravity and electromagnetism. For instance, there are tasks that model photon emissions and absorptions. Picture this. You define a task where a specific charge site emits photons under certain conditions, and then another task absorbs them back. It's like setting up a very precise dance between energy and particles, each following the rhythm dictated by the laws of physics. Now, for those of you who might be technically inclined, there's even a simulator developed in Python that allows enthusiasts to experiment with these concepts. The simulator isn't meant to be a high-precision physics engine, but rather a playful, educational tool to explore the boundaries of constructor theory. Think of it like crafting your own science fiction universe, where the laws of physics are rewritten. And just to give you an idea of how this works in practice, let's imagine you're interested in seeing how a photon could interact with an atom in this constructor environment. You'd essentially set up a series of tasks: emission, absorption, and the interactions in between, creating a branching pathway of what can happen. It's like being the puppet master of these subatomic events. I think it's exciting to think about how this kind of framework could influence future technologies, maybe even leading to revolutionary advances in computing or materials science. Just think of the innovations that could arise if we start considering what tasks we want our materials or devices to perform, instead of constraining ourselves to only what we think is possible within traditional physics. Before we wrap up, let's consider a thought-provoking question as we look to the horizon of scientific discovery. What if the limitations we perceive in current technology are simply tasks yet to be defined? Could constructor theory be the key to unlocking potentials we haven't even dreamed of yet? Thanks for joining me today on this exploration of constructor theory. It's a complex yet thrilling discussion, and I hope you're as excited about these scientific possibilities as I am. Until next time, keep questioning and keep exploring.